This is TinyTrek. It's a robot platform that I helped design and build. TinyTrek was designed to be an open source learning platform for teaching concepts about modern connected vehicles. The platform is based around a small vehicle that runs on a collection of microcontrollers and a Raspberry Pi.
The components attempt to mirror typical devices in a vehicle, such as a BMS for energy management, motor controllers, sensors, an over-the-air update system, multiple on-vehicle communication buses, and embedded Linux.
I worked with Andrew and Kyle to help build this platform and teach a connected vehicles special topics course at the University of Tulsa for the fall of 2024. The idea was based on a much older project I worked on in grad school called the Cyber Physical Testbed, which was supposed to be a sort of capture the flag style game with the vehicles. I built the first version of that robot, and another group of students picked it up when I left. We set out to update that idea, building an open source design that could be used for teaching experiments. For TinyTrek, the body of the robot is, of course, 3D printed. Attached to that, we have a Raspberry Pi 4 as the main brains of the vehicle. Think of that like the infotainment or telematics system, the thing that typically powers the touchscreen in newer cars. The two motors are small stepper motors with off-the-shelf drivers. Each motor has a microcontroller that talks to the Pi over CAN, a common type of networking used in vehicles. The microcontrollers for each motor are just doing simple control of the stepper drivers, nothing fancy. We wanted to have some intelligence for the battery system to behave somewhat like a real vehicle, so we added a dedicated microcontroller for battery management. It doesn't really manage the battery so much as control the energy flowing in the vehicle. The batteries we chose to power it are knockoff Milwaukee M12 batteries, mostly for cost. We needed to build a dozen of these things for this class, and these worked fine since we aren't really putting heavy loads on them. We printed some M12 receptacles from an existing design, which I modified slightly to attach to the TinyTrek chassis. When the physical power switch is on, our BMS supplies 5 volts power to the microcontrollers, and 12 volts directly from the battery to power the Raspberry Pi. We also want 12 volts directly from the battery to the motors, but we don't want that flowing all the time, so we put in a relay that has to be closed, simulating a contactor from an electric vehicle. This mimics the low voltage and high voltage systems in electric vehicles. It means we can simulate safety interlocks, such as making sure the motor power is off when we're running a software update. We have 2 motors, effectively giving us a rudimentary tank drive since we control each motor independently. Instead of adding more wheels, we just added a simple ball caster at the rear of the vehicle. This means we can do sharp turns or rotate in place. It also cuts costs because the wheels and motors are pretty pricey parts of the vehicle. We designed the vehicle so that you could add other sensors as needed. We just built one as a proof of concept. The sensor uses basic ultrasonic to detect objects in front of the vehicle. The idea was that we could implement a simple version of emergency braking when the vehicle sees something in front of it. So we built a platform, we taught the class, and we're going to put up all the files on GitHub and printables. If you want to make one for your project or experiment, or use TinyTrek for a class of your own, go for it. Check out the links in the description and feel free to comment on the project if you have any ideas or want to contribute. We have some more ideas for TinyTrek, and we'll update the GitHub as we go. Have fun trekking!